Hello and welcome to another series of lectures by Sasi Prakash on transportation engineering. In these lectures, we will look at four different types of problems asked in transportation engineering subject. First type of question is based on geometric design of the highway. The second type of question is based on pavement design, and third, material testing for traffic engineering. In geometric design of highway, we study about the geometry of the curve of the highway, geometry or the curve of the highway. So we divide it in two parts: horizontal curves and vertical curves. On horizontal curve, we study extra widening, on how much extra widening must be provided on curves, and setback distance, how much setback distance is required for building line. Then we study super elevation, how much we have to bank the road by by how much degree we have to bank the road such that a vehicle can safely maneuver a curve. Then in vertical design of curve, we study valley and crest curve and valley curve. So we will find out the maximum length of a crest curve or a valley curve using SSD and stopping side distance and OSD, and using the criteria of comfort or safety or etc. So in these kinds of things we study in geometric design of highway. Then we will study pavement design. There are basically two types of pavements: flexible pavement and rigid pavement. So in flexible pavement we study three types of design: CBR method, triaxial method, and Burmester method. CBR method is purely empirical method. Triaxial method is based on experiments, triaxial loading experiment of the soil. Then Burmester method is purely theoretical method. So, and then we have formulas for design of rigid pavements. So we will get to look at that. Take a good look at that. So then we will study material testing, in which we will study bitumen, properties of bitumen, VC30, what is meant by VC30 or what is meant by VG30 or VG40, etc. And then we will also study properties of aggregate. So what is the toughness or strength of aggregate. Then also we will study for rigid pavement, we will study cement properties, cement fineness and settling time, fineness and settling time, etc. Then at last we study traffic engineering. In traffic engineering we study signal design. There are three types of signal design: triaxial, cycle method, pedestrian crossing method, and Webster method. So we will take a good look at that too. Then we will find stopping side distance, overtaking side distance, and capacity of rotary in the traffic engineering section. So first we will start with geometric design of highway, and we will study vertical curves first. So let's start with vertical curves. So vertical curve can be a linear curve or a parabolic curve or cubic curve. So first we will start with the longitudinal curve or linear curve, which can be upslope or downslope. So we have to find stopping side distance, stopping distance of a vehicle if maneuvering on that slope. So for what is being done here is that first this is TR, reaction time, T reaction time. This is the time which the driver requires. This is the time which the driver requires to decide whether to stop, to apply the brake or not. So this is the reaction time. Suppose the object is here actually. He has to stop here, and the driver is here. Then he decides to apply the brake. So this is the time. This is generally about 2 seconds. He takes generally 2 seconds to decide, see the object, and then decide to apply the brake. So that is true. After he applied the brake, the vehicle actually skids for a distance L. So we have to find both, as the stopping distance covers both the vehicle reaction time, reaction distance and the skid distance. So why this is simple. Reaction time is given 2 seconds and velocity is given, suppose 60 kilometers per 60 kilometers per hour. So like vehicle V times T R equals to 60 into 1000 over half. We will convert this into meter per second. 60 into 60. This is and into 2 seconds. So 1, 2, 1, 60, 66, oh yes, 6, 2 seconds to 2, 3, or actually 33.33 meter. So then the skid distance is, suppose the velocity, here is v and here is v, and then after that velocity decreases up to 0. So it was moving with a constant velocity. So to find the speed distance, we will actually apply the conservation of energy. So total kinetic energy of the vehicle is half mv squared. Then that kinetic energy gets lost into the frictional energy between the between the wheel base and the road, and that will be equal to half mv square equals to uh, plus the potential energy gained by the vehicle. First, we will add the potential energy to half is m times g times this distance is actually this. If this is L and this is theta, this is L and this is theta. This that will be L sine theta. L sine theta plus the friction force is mu mg friction force time distance will be the work done by the friction. So that will be mg l mu mg l distance will be l cos theta, actually l cos mu mg l cos theta. Then we will arrange m will cut down, and then we have to find l, and l is equals to here the LDL. We will divide the whole thing by cos theta. So this will be cos theta, and this becomes cos theta. So this becomes tan theta, and this becomes cos. If theta is very less than 1, so then cos theta equals to 1. Okay, so this becomes b square over 2, and then gl 2g, b square over 2g, and here comes the tan theta. First we will write the mu plus tan theta equals to L. This is the formula. L equals to b square over 2g mu plus tan theta. So if the slope is upwards, actually, so if the slope is upwards, then there will be plus here, because, and if the slope is downwards, there will be minus here. So plus minus tan theta. If the slope is downward, if this becomes minus, so the whole thing, if the theta is, if this increases, this thing decreases, and this whole thing increases. So that is obvious from the physical situation here, that is okay. The vehicle is moving downwards, the length will be greater downwards when skid length when the vehicle is moving upwards, because of this relation. If the angles are very less, if the slope is very less, uh, we can consider it, take it as a second degree parabolic curve, because the solution will be simpler here. Similarly, for the valley curve, we have two criteria. First one is the comfort criteria, and second is the safety criteria. Comfort criteria is driven by the jerk, and jerk is actually accession with respect to time. So for comfort criteria, ideally this should be a cubic third degree curve, because we will see that the equation how the equation comes at third degree. Okay. Then safety criteria is given by the headlight at night. Safety at night is given by the headlight distance. Okay, so first we will study crest curve. Crest curve. Okay, so this is N1, and this is N2. Is the slope, upslope, and the downslope. Actually, this could be anything, upslope and upslope. So this could be like this. Upslope, a greater upslope to lesser upslope. So this could be like this. N1 and N2. And what we do is actually this is N1 minus N2. N1 minus N2. This deflection angle is N1 minus N2. Here, this will be N1 and this is N2. So actually we sum it. The general algebraic formula is N1 minus, and this is negative slope, so we will put a minus N2 here. So this becomes N1 plus N2. N is the deflection angle. So we have to derive the formula for this curve. So this curve, actually what we have to derive is, suppose this is second degree curve. This is a second degree curve, and y and x coordinate and y coordinate are given here, and this is y1. So we can write the general equation of a parabola. Y is second degree equation: a x squared plus b x plus c equals to 0. Here at x is equal to 0, y equals to 0. So x equal to 0, y equals to 0 gives c equals to 0. Then we will find dy over dx equals to 2ax plus b. At x equals to 0, at x equals to 0, we have dy over dx is equal to n1. So that gives b is equals to n1. Okay, and at x is equals to l, we have dy over dx is equal to minus n2. So we will put that here in equation. So minus dy by dx minus n2 equals to 2a l plus n1. Okay, so 2al plus n1, b is n1 actually. So from that we get okay, we will okay, n1 n1 plus n2 equals to minus 2al. Okay, or we can say that a equals to minus of n1, we will write it as bigger n by 2a. So our final equation will be y equals to a equals to minus n over 2a minus n over 2a is that 2l actually, minus 2l, and x square, then plus bx, plus b is how much, n1 times x. So what we do not need to find the coordinate of vertical coordinate of the pavement from the initial point. We actually need to find from the vertical coordinate We actually need to find y1 here. Actually, the tangent here at the first point minus the coordinate. So y1 equals to, the equation of this line is n1 times x. Okay, y equals to n1 times x. So n1 times x minus of minus, that minus n over 2l x square, and then minus n1 x. This cancels out. So y1 is equal to n1 n x square over 2l. Very simple formula. Nx square over 2l, nx square over 2l, where x is the second degree, x is the variable here, and ny2l, n over 2l is the constant. Similarly, if we find for a third degree curve, this comes 2 over 3 over n over l square x cube. Simply extrapolating this equation, we can see 1 over 2, then 2 over 3 n or l square x cube. Okay. This is why dimensions, this will be correct. So l, this is the two dimensions of the length and one dimension of length. So finally one dimension of length, three dimension of length and two dimension of length. If we cut that, we get one dimension of length, that is y. Okay, so just then n over 2l into x square. Now we will find the now we can take a problem here. The problem was from gate latest key. Okay. Um, choice. Problem was that a parabolic vertical curve of n1 is given 5 plus 5. N1, this is given plus 5 degree, and this is given minus 3 degree, percentage, minus 3%, and this is 5%. And the length of the vertical curve is 400 meter, and from this distance to this distance is 400 meter. We have to find vertical point of curvature is located on the road grade of 5. This is the vertical point of curvature. Okay, this is the vertical point of curvature, and the vertical point of intersection. This point is called vertical point of intersection, VPI, and this is called VPC. A intersection is the point of intersection of the tangents drawn at the two ends. Okay. So we have to find the height difference between VPI and VPC. Okay, so this is the formula n over 2l x square. So we will put this is the formula of y1 actually. So this is what we are asked is y1 here, and we have to put the value of x. So n is equals to 5% plus 8%, 0.05 plus 0.03. This is point percent. N is 0.08. Okay, 0.08, then 2, then 400, then x के value हम लोग के output करना. We have to put it here. X the value of x. X is this point. So actually, if total length is L, this length is given by n1 over total n into L. That is the value of x. Actually, this let's draw it here. If this is a curve here, and so this distance is, if these two distances are distributed such that this is n1 and this is n2, so this will be n1 over n1 plus n2 times L, and this will be n2 over n1 plus n2 times L. This is the student says that. So we will put the value of x here. X is equals to n1. N1 is 0.05 over total 0.08 into L के value 400 का square. We will solve this. So this becomes 5, this becomes 8, this becomes 40, पचास 40 ठीक है तो 50 this becomes 250 का square 250 times 250 times 250 and this is 0.08 we will actually have to cut this and multiply okay 8 25 4 times 2 times 2 this will be cancelled and this will put 6.25 this comes 6.25 this distance is 6.25 meters so now we will derive the now we will derive the general length of the curve in terms of stopping side distance and SSDs. So we just need to remember that formula. N over 2L times x square. To find the length of the curve, we in terms of stopping here we have I have shown here that if the vehicle is here and the vehicle's driver's eye is here and there is another object here H2 and this is the to see the object clearly we draw a tangent such that the tangent meets the road and that the object driver's eye the road and the object are in one line and it tangential to the road. So what we will do is we have found the formula for this h1 equals to h1 is equals to this formula n over 2l x square where x is this distance so this is s1 square this is s1 then h2 which equals to n over 2l s2 ka square this is s2 this is s2 this is s2 so what we will do is actually we do not know s1 and s2 individually but we do know s1 plus s2 is equals to s or ssd stopping side distance so yeah or overtaking side distance whatever it may be so we will put s1 equals to just call it s so s1 equals to in the root h1 okay 2l over n and then h2 equals to 2l over n and the root h2 then we will add these so this is common both so and we have to square 2l over n will take common and then square it that becomes that and then h1 under root h1 plus under root h2 square equals to s square so what we get is l equals to n times a square n times a square n square over 2l under root h1 plus under root h2 ka whole square. Now the common problem is here that the driver's eye is actually considered to be 1.2 meter above the road surface and the obstruction is actually scale height normal scale height 15 centimeter. So if we are finding stopping side distance if s is here stopping side distance this becomes 1.2 and this becomes 0.15. So in that case, this is a constant which comes to be, this comes to be L equals to, if we solve the equation, this n square over L, n square over actually 4.4 L. This comes to be 4.4. This is a constant and this two are given. So, and if we are given OST, that both height are 1.2 meters, then in that case L is square over 9.6 L. This is the case where the stopping side distance is L S actually S. These are the cases where S is actually less than the total length of the uh, curve. What happens when S is greater than the length of the curve? In that case, the derivation is somewhat difficult, but what we'll do is a trick. So L equals to, what we will do is differentiate this to S then minus, and this, the remaining part will be subtracted, but the reciprocal of that. Oh, L is here actually. L is here. So n square over 4 over 0.4, n square over 9.6 for OSDs. If the length, if S is greater than L, this is for S less than L. Stopping side distance or overtaking side distances are less than the length of the curve. Then these equations apply. N S square over 2 under root h1 plus under root h2 whole square. So in that case, if L is less than S, then 2S minus reciprocal of that under root h1 plus under root h2 whole square times 2 over n. Okay, next we will solve a problem here based on the trace curve. So what's given is that a 3 degree curve, 3% curve meets a minus 2% curve. For design speed of 80 km, we have been given a stopping side distance of S is equals to 120 meter, and actually 1.2 meter, h1 is equals to 1.2 meter and s2 equals to 0.15 meter. In that case we get 4.4, the constant that comes in the formula. The curve length which needed to be provided is, so what is the formula? L curve length formula n square over 4.4 in this case. H1 and H2 are given. If the value were something other than 1.2 and 0.15, we would have to calculate that value. And if both are 1.2, in that case for n s square over 9.6. So we will put the values. N is equals to 3 plus 2, 5%. 5% means 5 by 100 into s square 120 meter. 120 into 120, and this is 4.4. Okay, so 4.4, we will cut 100 here, and 4.4 say 20 here, and we will cut 411, 411, and actually we will, this is 11 and this is 12, so 1 plus something. Now everything downstairs have been calculated, and upstairs 50 times 3 is 150. 150 plus actually. So what we get is that L becomes greater than S. So in that case, we cannot apply that formula. That answer is incorrect. So we will have to apply the formula 2s minus 4.4 over n. 2s minus 4. This is the reciprocal here. So 2s2 into 120 minus 4.4 over n is 5%. 5 into 100. So this actually becomes, and this is, so 240 minus 88 is to 5152. This is the answer 152. That was 150 plus something. So this is answer. L is equals to 154 meter. Now we will derive the equation for the valley curve. Valley curve equations for the valley curve. We use two criteria for valley curve. The first criteria is the comfort criteria. The second criteria is the safety criteria. The first criteria, the comfort criteria. Valley curve. First comfort criteria. Comfort criteria is given by jerk. Jerk is actually acceleration d acceleration over dt. This is constant. Jerk should be constant. This c is given in the form. This c is given. Jerk. This c is given in the question, and we have to find acceleration with respect to time. So if the vehicle starts from here and goes to here, this point, so the acceleration here is v square over r. This is the radius r, and acceleration, centrifugal acceleration here, there is v square over r, and here is acceleration is 0, and the total time taken by the vehicle moving the velocity v is L by 2. The distance covered is L by 2 over v. So if we arrange this, we get 2vq over LR. This is the equals to c. This equals to c. We have to now we have to find the length of the valley curve L. So L equals to 2vq over CR. Now we do know the velocity of the design velocity and the C jerk design jerk. We do not know the radius of curvature of the valley. So we will actually derive we do know the formula for the y is equals to 2 over 3 n over L square x cube is the formula, is a third degree curve equation. So dy by dx dy over dx is equals to 2 over 3 into 3 n over L square x square. 3 cut or d square y over dx square equals to actually 4n over L square into x. Okay. Now we will this is actually 1 over r. This is 1 over r equals to d square y over d square. Well, so if we put 4n L over 2 and x is equals to L over 2. Total length L over 2 L over 2 L over 2. So this is becomes 2. This equals 2. This becomes 2. 2n over L. Radius becomes 2n over L. So this we put the value of 2, we put the value to n over 2. This is actually 1 over r. No? So this is 1 over r. So it's actually L over 2n. So L square is equals to 4n VQ over C. So L is equal to 2n VQ over C. This is the formula for the comfort criteria. 2n VQ over C times L. Now we will derive the length of the valley curve for by safety criteria. Okay. So this all criteria we'll just put it here. L equals to 2 times NVQ over C by comfort criteria. But second is safety at night. So what we do is, here the vehicle is height is headlight height is 0.75 meter. Headlight height is equals to 0.75 meter. Okay, and this angle is 1 degree. 1 degree above the horizontal. So this distance x we have to find. We will multiply it by 2. No, okay. Okay. This x is actually s, stopping side distance should be there, and this is y. So y is equal to how much? Y is equal to h1 h plus this is s tan alpha. This is s, so this is s tan alpha. This is h plus s tan alpha. Okay, y is equal to s tan alpha. Again we will assume that the curve is parabolic. So the formula is y is equal to n over 2lx square. So we do know this is s, x becomes s here. So we will equate here y equals to h plus s tan alpha, y equals to s tan. So from this we get that L is equals to n s square over 2 times h plus s tan alpha. If we put the value here in s square 2 times 0.75 plus s is tan alpha. If we put the value of alpha equals to 1 degree, this becomes 0.035. okay, ns square over 2 h 0.035 s plus 0.75. So this is the formula for safety criteria by, this is formula for length of the crest curve by safety criteria. If length is less than s, if length is greater than s, then what happens? If length becomes greater than s, then we actually 2s, n is equal to 2s minus reciprocal of the remaining thing, 2 times headlight distance h plus 0.035s over n. So this is the formula if L becomes greater than S. So that's okay for, we can solve a problem here on